Hello, everyone. Thanks for joining. I'm Adi. I'm an engineering architect from the Microsoft product group. I've been working at Microsoft for 10 years. In the last few years, I've been working with customers who use Azure Database for Postgres and Cosmos DB for Postgres. I've been helping them in their complex Azure Database for Postgres implementations. And I've also been helping them in solving their performance and scalability issues. In this session, I would like to talk about partitioning in PostgreSQL and how it is similar and different than Oracle. I would like to share my experiences about strategy and tools that can be used to efficiently migrate partition tables from Oracle to Azure Database for PostgreSQL. A little breakdown of the session for the next 20 minutes. I understand that this is very limited time to discuss about this topic in detail, but what I would like to do is talk about the scenario end to end. The expectation from this session is that I can share the process, the experience, and tools that you can use to migrate partition tables from Oracle to Azure Database for PostgreSQL. And I believe after the session, you can take in all those learnings and the tools and try it at your own pace. So many customers are moving to Azure Database for PostgreSQL Flexible Server, and they often ask me, how do you do these migrations efficiently and at scale? Sometimes they are concerned if their queries would run with the same performance like how it ran in their current database platform. Sometimes they are concerned if the partitioning strategy that they used with Oracle would continue to work well with the new environment. Because they do understand that there are some differences in the partitioning between Oracle and PostgreSQL. They also wonder how they can effectively manage these partitions in Azure. So to talk about partitioning strategy, there are several motives for partitioning a table. By partitioning huge tables, we are splitting them into smaller tables. And of course, that can improve query performance because now instead of scanning through the entire table for the results, the query is going to scan only those smaller tables. And of course, due to partition pruning, that means the query is going to scan through only the subset of data rather than scanning the whole table. It could also reduce index rebuild times because now the data is organized and it has to rebuild only a subset of data. If your application does a lot of bulk inserts and bulk deletes, then that could happen efficiently if the table is partitioned because you operate only within that partition and other partitions remain untouched. The database also becomes very manageable. Let's say you want to archive old data. You want to offload that old data. You want to reduce the database size and offload it to a cheaper storage. Let's say you want to offload it to Azure Data Storage, Azure Blob Storage. In that case, you can do it if your table is partitioned, and this doesn't affect your application's performance. So you can do it. You can do it in a much efficient way. Partitioning also reduces vacuum overhead. So vacuum is a process where storage is reclaimed. Storage by debt tuples is reclaimed in PostgreSQL. And that becomes efficient because the vacuum process doesn't have to scan through the whole table to claim the storage back. And this also reduces table bloat. Because if you have a lot of, let's say if you have a huge table, then the vacuuming is going to take time. And if that vacuum was not able to finish within a particular time, then it is going to cause table bloat. And in a way, partitioning actually reduces table bloat. Finally, a good strategy solves your business requirement without compromising your performance and SLA, performance SLAs or budget. So partitioning is not actually a magic solution to solve all your performance problems. Applying partitioning can be counterproductive too, because I've seen in some cases. So it was with one of my customers who are very proactive. They applied partitioning to almost all the tables in their database, and that was very counterproductive because what they found was that they didn't do any kind of analysis on how they should partition the data, and then once they ran the performance tests, they found that their queries are actually executing slower than unpartitioned table. So it is very important to choose the right partition key based on the data access pattern, ingestion pattern, and query pattern. And just like how partitioning is important, archiving old data is also important. So remember the case where I talked about offloading the data to a cheaper storage to save some space. You need to put the right process in place so that you can offload the data to a cheaper storage based on your data retention requirements. Well, of course, you need to keep all this in mind if you're doing a greenfield development. That is, if you're developing an application from scratch. But if you are migrating from an existing setup, let's say you already have Oracle in place, then there's a probability that you're already doing all of this. You've taken care of all of this. The good thing is that your existing partitioning strategy can be applied in PostgreSQL as well. In most of the cases, you can continue to use the same strategy with minimal changes. So let's look at the feature parity difference between Oracle and PostgreSQL. So from a feature parity perspective, Oracle and Postgres engines are similar when it comes to partitioning, but there are just a few minor differences. Both Oracle and Postgres support list, hash, and range partitioning, and both support subpartitioning too, which means you can have a combination of list and range partitioning within a table. So the good news is that, like I said, you can continue using the same partitioning strategy that you have in Oracle in Postgres after you migrate to Postgres. A few key differences is that Oracle supports automatic partition creation. In Postgres, you will have to manage that on your own. But then you have tools to do that, which can automatically create this partition and manage the partitions for you. And the other key difference is that in Oracle, you can split a single partition into multiple partitions, and you can merge partitions. In PostgreSQL, that is not possible, but you can do it with a bit of workaround. And in PostgreSQL, the partition table itself is a virtual table. That means all the data is stored in the child table, which are the partition tables. And whenever you insert a row into the parent table, the data is routed based on the partition key to the right child table. And that holds the data. If you were to update a partition key, then the data is automatically moved to the right table based on the partition key. So let's look at the steps for migration. So first step would be to convert the schema using Ora2PG. So Ora2PG is a super cool open source tool that you can use to convert schema from Oracle to PostgreSQL. It is a tool, it can run in a VM, in a Windows or a Linux VM, or it can run in a Docker as well. You specify the target, the source, and the target connection string, and with a few with a few commands, you can actually convert the Oracle schema to Postgres schema. And there's a lot of extensive documentation. It's an open source tool. There are a lot of contributors to it, and there is a lot of extensive documentation on the tool. And the author is super helpful and responsive. So it's a really cool tool to use. And you can use Ora2PG to automatically convert partitions tables for you into PostgreSQL. There are two options. You can either deploy them directly to the target, or you can export the PGSQL scripts, and then you can deploy them manually, which is what we are going to do in the demo. And in the target, each partition table is a separate physical table. We'll see that in the demo in a bit. And this enables us to load the data in parallel. And after you load the data, you create the indexes. And in this whole process, data migration is one of the key challenges, or is one of the major challenges, because if your tables are huge, then it can take a lot of time to load the data. And we want to load this data as soon as possible, as quickly as possible, because until you finish loading the data, you cannot cut over your application. So if it's a business critical application, then you cannot afford much downtime. So you want to complete it as quickly as possible. There are several parameters which determine the time taken to migrate data from Oracle to Azure Database for PostgreSQL. be it. So because it's a production system, your Oracle might not accept. I mean, you might not be able to um, um, fire many queries to that system. So you'll have to limit those number of queries that you can fire to the source system. The network throughput between the source and the target acts as a parameter. So depending on the type of connection you have between the source and the target, the time taken for data migration might vary, and also the target compute size. So you need to also see what compute size you have on the target, and then you will have to scale it accordingly in order to make the data migration much faster. There are several tools that you can use to migrate data from Oracle to Postgres. In this session, I'm going to use Azure Data Factory, which can load data in parallel. Azure Data Factory is a cloud-based ETL tool that you can use to copy data from one source to another. In this case, from Oracle to Azure Database for PostgreSQL. So in the earlier part of the session, we talked about, I spoke about a key difference between Oracle and PostgreSQL, where Oracle can automatically create partitions for you. To bridge this gap for time series and serial-based data, pgpartman is a useful extension in Azure Database for PostgreSQL, which you can use to manage partitions in Azure. And this can create partitions automatically. So using pgpartman, you can also manage archiving of data or dropping old partitions that are not needed in a cascading fashion. So pgpartman automatically deletes old partitions for you, as well as creates new partition as the data comes in. And the other important use of pgpartman is that it can also convert an existing table into partition table without affecting the live application. I won't be covering this part in this session, but I thought of mentioning it as a pointer so that you can read about it later. So let's see a quick demo on how the migration looks like end to end. So I have a system logs table here in my Oracle environment, and I have partitioned it by list based on categorical values. I have categorized error 1, 2, 3 as warning and 4, 5, 6 as critical. So there are two partitions in this table. So let me quickly show you how the data looks like in this table. So you can see this is how the data looks like, and you can see the error code here. Let's look at the count now. Let's see the number of rows in this table. So this table has around 170,000 rows, and this is split in two partitions. One has 101,000 rows, and another one has 69,000 rows. I have another system logs table, which is partitioned by date ranges. So there are three partitions in this table, for every year, 2020, 21, and 22. And let me show you sample data from this table. And this table has 300,000 rows, which is distributed in three partitions, each having 100,000 rows. Now, I have already executed ORA2PG, and I have exported the script, which we would be running in the target flexible server. So here I have my Azure Data Studio open, and I've connected to Azure Database for Postgres flexible server. And let me create this table. So this is the first table, system logs, which is partitioned by error code column. It's completed. Now let me create the partitions as well. I'm creating the two partitions, the warning partition and the critical partition based on the error code values. And this is my other table, system logs table, which is partitioned by date ranges. I'm creating the similar partitions here, each partition for one partition for a year. And now let's look at these tables from the table explorer. Let me just refresh this. And you could see here that the partitions are created. You can see the system logs table with 3 partitions for every year, and system logs table with 2 partitions, one for critical and one for warning. Now, what we'll do is we'll use Azure Data Factory, which is a cloud-based ETL tool to run the data migration. So I've created a simple copy pipeline here, which will copy data from Oracle to Azure Database for Postgres in a parallel fashion. So it's going to, now when I click debug, it's going to copy data in parallel from all the 5 partitions. And what you would see is 5 copy activities, which will run in parallel. And you can see here the 5 copy activities are queued. And are running in parallel. And you can see a few of them have succeeded, and all of them have succeeded. So the data got copied from Oracle to Azure Database for Postgres. And now let's look at the row counts. You see that the target table has 170,000, and this was split in 2 partitions, 101,000 and 69,000. Now let's look at the other table, which was 300,000 split in 3 partitions with 100,000 rows in each partition. The whole migration that we saw was driven using a metadata table, which contained the details of the partition which needs to be copied. And Azure Data Factory used this table to query the source and copy the data parallelly. And in case you have many more partitions, what you would do is you would enter those rows into the metadata table, and then those partitions would get copied. We spoke about pgpartman in the earlier part of the session, where you could manage the partitions automatically. So I have an events table here, which is partition, which has event data and is partitioned by date ranges. And I'm going to create some old partition here, one for January and one for February. Let's see how we can manage these partitions, manage the stable partitions using pgpartman. So now it's created. Let's go to Table Explorer and see if these are created. You can see here that both of these partitions are created. Now let's insert some data. Okay, let's see if the data is inserted. Yes, you can see here that the rows were inserted for 31st and 1st of February. Now we would create partition for the table using pgpartman functions. The function accepts a few parameters in order to achieve this. So it first accepts a parameter, the table name as a parameter, which is your p_parent table. And I supply the name of the table here. P control is the partition key. Type is the type of partitioning. It's either native or pgpartman. And pgpartman is for older version of Postgres, lower than Postgres 11. Native is recommended for Azure Database for PostgreSQL. Interval is how how this partition should be. The supported are yearly, quarterly, and you can see all of those supported values there. Pre-make is basically the number of partitions that you want pgpartman to make. So I've specified 30 here, which means it's going to create 30 partitions before the run date and 30 partitions after the run date, which means that in total it's going to create 60 partitions for this table, public events. So let's run it. So it returned true. Now let's go to the Table Explorer and see. You see that there are 60 partitions here. Let's run the partition query to see this better. So you can see that the earlier partition is 18.2, which is 1 month older, and the latest partition is 19.4, which is 1 month later. And we can also see the two partition at the beginning, which we created at first. To clean up and create new partition to manage the partitions, we would be using the run_maintenance function to do that. But first, we need to update the metadata table used by pgpartman, which is part_config. We need to set a few parameters there. We need to update a few parameters there for every table that we want pgpartman to manage. So in here, I have set the retention as 3 days, and I'm updating this config now. So what happens is when I run the maintenance method, maintenance function, it's going to drop all the partitions until day before yesterday, and it's going to retain all the future partitions. And if and it's going to create any new partitions that needs to be created later than today. So let's run this. It's complete. It's complete. And let's query the partition table. And you could see here that it has dropped all the partitions before 3 days, until 3 days before, and you can see all the future partitions intact. And if you were to automate this, you would use the cron job using pg-cron, which is also available in Azure Database for Postgres. So that was a quick demo. Now, okay, so I would like to share some important links that could help you in your data migration journey. You can find these links in the description of the session because these links are not clickable in the video. So you can please feel free to check them out from the description of the session. So with that, we have come to the end of the session. Be sure to visit the links that I had shared earlier. We've also published a detailed migration doc, which you can see the link below, which has scripts and a lot of useful information that you can use for your migration to PostgreSQL, and feel free to check them out. And that's my email address. Please feel free to reach out to me using my email address in case you have any questions regarding migrations to Azure Database for PostgreSQL or Cosmos DB for PostgreSQL. I'll be happy to answer them. Hope you're enjoying Citus Con, and thank you for watching.